Finland is a land of quiet beauty, filled with vast forests, clear lakes, and peaceful landscapes. In winter, the northern lights brighten the skies, while summer brings long, calm days. The Finnish people are known for their resilience, honesty, and strong connection to nature. Modern yet simple, Finland offers a balanced way of life where nature and everyday living exist in harmony.
Okay, my name is Muhammad Nakib. And today I would like to talk about Finland. So, Finland is a beautiful country located in Northern Europe, known for its peaceful environment and high quality of life. One interesting fun fact about Finland is that it's consistently ranked as one of the happiest countries in the world. In addition, Finland is famous for its strong education system and clean natural environment. However, like many developed countries, Finland faces changes in its population. The population can increase due to factors such as birth rates and immigration. Today, we would like to explain more about this from showing a number of population, calculation of population growth, graph and more reason of this happen. Without further wait, we begin.
So, let's moving to the calculation part. So, I want to ask you, how do we predict the future of population? To answer this, we're going to use the exponential growth model, where A is the year we start, K is how fast we're growing, and T is for time has passed. So, for our formula here, I'm going to take year 2000 as my T0. By looking at the growth just 1 year later, we can calculate our growth constant K, which come out to approximately 0.000535. Now, we have our engine. Let's take it a test drive. To see this model in action, let's look at two milestones, which is a past value and a future value. First, for the past value, I will take 2010 using a 9 years interval, which is T equal to 9. We're going to get our formula prediction. Population is 5,201,185. Next, we're going to the future prediction. We fast forward to 2013, which is T is going to be 29. The model shows the population climbing to 5,257,137. You can see the steady climb as the exponential does in work over time. Thus, the equation already proved the answer. Let's move on to the graph part.
Alright, now I will be presenting about population growth in Finland, focusing on the difference between expected values and actual population trends. Population growth is influenced by several factors such as low birth rate, aging population, and migration in Finland. Recent trends show some interesting changes that differ from earlier predictions. From the particular solution, we can see that the calculated population value does not exactly match the actual population, and this difference occurs because mathematical models usually assume ideal condition, while in reality, population growth is affected by social, economic, and political factors. One of the main factors is the low birth rate. Finland has been experiencing historically low fertility rates, meaning fewer babies are born each year, which slows down natural population growth. In some cases, result in death exceeding birth. In addition, Finland has an aging population when a large proportion of people are elderly. This leads to higher death rates and lower overall population growth, creating a greater dependency on younger workers and making migration even more important to sustain the population. Economic and social factors also plays a significant role, such as the high cost of living, career priorities, and delayed marriages, all of which contribute to people having fewer children.
Now I will present the graph for our population study. First, let's take a look on the graph. The blue point represents the actual population data collected over than 20 years, while the red curve shows the theoretical model from a differential equation. On the horizontal axis is time and the vertical axis represent population size. Both the data and the model show an increasing trend, meaning the population is growing over time. However, the actual data has slight fluctuation due to real-world factors, while the theoretical model is smooth because it assumes a constant growth rate. Overall, the model is close to the real data but not exactly the same, showing that mathematical models can estimate population growth but cannot fully reflect real-life situation. Thank you.
Alright, at first glance, the numbers seems to align. Are the values consistent? The exponential model show a steady increase in Finland's population over time. Interestingly, this matches the real population trend quite well. Both the predicted and actual data reflect gradual growth. However, as time goes on, a gap begins to appear. The predicted values fall slightly below the actual population, especially in later years. This growing difference suggests that while the model captures the general trend, it doesn't fully reflect the complexity of the demographic changes. So, how far off is the model really? When we calculated the percentage error, a clear pattern emerges. In 2006, the error is relatively small, about 1.39%, but by 2025, it rises to 6.71%. This increase tells us something important. The model becomes less accurate over time. Why? Because it assumes a content growth rate. In reality, population growth is influenced by changing conditions, social, economic and demography, and these changes cannot be fully captured by a simple exponential equation. That's it, thank you.
Alright, so now I will talk about the factors that influence population growth in Finland in the past. To understand this, we need to look at how society developed over time. First is economic development. As Finland's economy grew, more job opportunities were created which attracted foreign workers and students. A study by Mika Raunia in 2005 also found that many foreign professionals view Finland's work environment as more relaxed and less competitive. Because of this, more people were willing to move there, contributing to population growth. Next is urbanization. Many people moved to cities like Helsinki for better education and job opportunities. Higher population density in urban areas also improves economic productivity and reduces infrastructure costs. This can make cities more attractive and supports population growth. Lastly is government and welfare policies. Finland can provide strong support systems such as healthcare, education and family benefits. This can improve quality of life and encourage people to stay or move there. Now, let's look at factors that may affect population growth in the future. First is the rising cost of living. As living expenses increase, people may choose to have fewer children, which can slow down population growth. Second is immigration. If the population declines, the government may rely more on immigration to maintain the workforce and support the economy. Last but not least is the government policies. Policies will play a key role in encouraging family growth and managing immigration. People are more likely to stay in countries that offer better opportunities and quality of life.
In conclusion, the exponential population models provide a reasonable approximation of Finland's population growth between 2000 to 2025. The predicted values show a similar increasing trend compared to the actual population data. However, the percentage error gradually increases over time, indicating that the model becomes less accurate for later years. The difference occurs because real population growth is influenced by complex factors such as immigration, declining birth rate, aging population and economic conditions. Therefore, while the exponential model is useful for understanding general population trends, it cannot fully represent the real demographic changes occurring in Finland.